Welcome back. Today I'm going to be continuing to work on Script and also make some changes to the underlying virtual machine as well. So last few days I've been implementing arrays in Script, and it compiles to the bytecode and all that. So what I'd like is when you create an array, and a string is an array as well, it also pushes the capacity of the array. Because you have to choose the capacity at the start, but it'd be nice if you get that as well with it. So, to do that, I need to modify the virtual machine, and then I'm gonna have to fix some stuff in the language. Yeah, this is like an offline stream kind of thing as well. So basically in here, here we've got insert memory. So this is basically setting the memory. So we don't push anything here. I think it's in inst out actually. Where we push it, right? So we push that. So I want it to be the top of the stack would be the pointer, and the one right below that is is this. So basically just push this back. Is that right? Yeah, pretty much. So just push this back. A and int. Yeah. And then we have to also change on the push stir, I believe. Push stir, yeah. So it's the same kind of thing here. And let's see, do we even have, we have the index. Oh shoot, but we don't have that. So we need to use the stir.len. We'll push that. And yeah, so that should be pretty much the only change that we have to make to the virtual machine itself. So that does not work. That's a size type. Okay. Yeah, so basically what I need to do is actually, so we need this to be a word. So let's do something like this, word, and then dot as int equals that. And then also for the other one, in alloc, right? We need it to be a dot word. And there we go. Okay, so now it compiles. And a lot of stuff in Script is going to break. Yeah, so if we try to run it, so let me just, let's see, you can get rid of this example. Let's make a simple hello world, right? Like hello world. This is gonna break because now we're pushing the size of the string, and then we're not gonna know the proper size of the stack. So that is like where we can start. Exit with exit 15 or whatever to make sure it's working, obviously. Yeah, so if I compile it, and actually I have this run sh now, so that's nice. Alright, hello world. So it still works, but the problem is we have leftover stuff on the stack that we don't account for. So let's quit out of this. Let me actually make sure it works, actually. That's probably a good idea. And tags on it. If we take a look at this, we can see here, if we do print, it's going to print the size of the string. If I am not mistaken. So, let's do run. And it didn't print anything. So why does it, oh shoot, because it runs me. Yeah, so just recompiled it and got rid of all the stuff I just did. So I'm going to have to manually do it, but that's okay. Print is here. Okay. Build has them. And same thing but with Tyler, the run type. And stack underscore. Okay. Shoot, did I not? I rebuilt everything. Maybe I just make sure. Yeah. Okay, just make sure everything's rebuilt. And then we can actually run things. There we go. Okay. Ooh. Okay, that's a weird thing with the characters. It's not. That's kind of. That is strange. Why this would happen? It broke all of the characters. What the heck? Huh. Okay, that was interesting. I don't know why that happened. But yeah, it's 14. So that's the size of the string. So that's actually correct. And the thing is, right, we had this, right? So that's 5, 6, 7, 8, 9, 10, 11, 12. Then we had the null termination character and the new line. So the null termination is sort of included in it because it's the capacity, not really the length, right? So that's sort of what we need to consider. So whenever we push that, we're going to have the capacity. It might not necessarily be the length of the string, and that's just the maximum amount of numbers you can insert, right? Yeah, so that is just something to keep in mind. So let's go to script, right? Source. And let's modify, not really the main.c, but the, really just going to be in the backend. So when we're handling it, right? So we can start with the native right. Because here, we need to pop off the length, essentially. So gen pop, right? Gen pop state in the file. And that's going to be good enough for that. So now this should fail, because it's going to be a stack underflow. If I go ahead and I do all this again. Actually, I need to do this. And we should have that pop in there now. No, because I didn't rebuild it, obviously. Yeah, now we have pop. So that's going to pop it off. And then if I try to put a print here, it is going to fail. And yeah, stacking the flow. So that is exactly what I wanted. So that is working out. So we're popping that off. And now the stack is correct. And anywhere else where we deal with pointers. So it's basically just in the arrays, right? Where we're allocating memory. So let's see. In here, here's the array allocation, right? So we gen alloc. So that's going to have the size of the array and the pointer. So we don't really have to do much here. We just need to know that gen alloc is inserting more elements, right? So we push that, gen expert. Yeah, so we need to basically just set the state stack size plus plus. It's going to be one greater than what we are saying here, because here basically we push one, generate the expression, right? So that is 2 on the stack, and then multiply, so that's 1 extra on the stack, and then we have the 1 pointer on the stack. But we also have the size, so we need to essentially just iterate it one extra time. Yes, and then so read and write, they don't take the capacity either, so I think that's fine. What we'll be able to use it for though is like we'll be able to check like boundaries and such, to make sure we're not overreading, right? So I don't know if I'm going to implement that now, but basically whenever we are writing to it, perhaps we could grab the capacity, because it should be right under the pointer location, unless something was messed up, but that shouldn't happen. We could probably even assert that. But basically we'll grab the capacity, and then if the number that you're trying to do is greater than the capacity, we could throw an error at runtime, right? Yeah. yeah. I think that is good. Because then, otherwise, you could probably cause it seg fault, because it's calling C code, right? So, seg faults. Yeah, so let me just go through and make sure I can get it all right. So, expert array, right? So we have this. So this is the index, and that's the variable location. So now it's pushing 2 things, and we know that. Yeah, so the variable location. Actually, it might be off now. The variable location may be off. Because I think it might be pointing at the number, right? I can try. Let's allocate an array, right? So, three elements. 1, 2, 3, just like that. Simple array. And then I'm just gonna try to let's just exit with x1, right? So it should be 2. I traffic fire arrays, and then I run it. Okay, so it still does work. All right, so I guess it's still pointing at the right one. It's just right below that we have the amount, right? So if we want to get the amount, I'm just looking at this, right? So if we want to get the capacity of it, we could just grab it, you know. So I should probably do that in the gen array offset, because we use that in a couple places. So it might be nice if we grab that, right? So if we do gen index, just do index -1, and we just need to assert that that is greater than 0, right? So maybe we could even just assert index is greater than 1. Var index, we'll need to check here. Var index is greater than 1. And then stack was corrupted. So basically, that means there's something wrong with the stack, right? If it is not. Because we have 2 elements on the stack, so of course. Okay, so we have this. So we can do that, and that is getting the capacity, and then actually generate the generate this, right? So this that we're going to add to the pointer, we can actually check by doing this, right? All right, -1. You know, just do -1 there. That's gonna be the size, and then we need to let's see, how does it go? So we need to compare them. How is that comparison? I forget the order that it works, but basically we need to well, actually that's gonna be kind of hard to throw an error like that. So maybe that should even be handled in the virtual machine, you know? Because otherwise this we're gonna have to like write a specific message and stuff, and I don't know that I want to deal with that. So maybe we won't even do that here. We still want to assert this because that means everything is still working. So I can check and make sure as well. Yeah, okay, so we are good. We're good with that. Okay, yeah, so maybe I won't actually check that. Because I can pretty easily check that on the level of the virtual machine when we're calling right. Because we know, do we know that? Well, I guess we don't really know the point. So maybe I should write something in the assembly that just sort of, like, prints errors, you know? Certain errors. I don't know. I will probably think about that later. Because this really is just about, it's just about trying to get the size with it. Because that's going to be useful, because I would, like, be able to do something like, once we have strings, specifically for strings, we could do stir.length. It's any string literal. Maybe stir dot capacity, right? Something like that. Any string literal, the capacity is going to also be the length of the string. So we are, good in terms of that. So we could use that for iterating over it and things like that. When it's not a string literal, it's a bit harder, and we'll probably need like a stir length function for that. But yeah, we could use that, and I think that'd be nice. That's sort of why I wanted to implement this, and then also for checking, like I was talking about before. So I think we're good. I think we are good. So I'm just gonna write a little bit of a more complex program and make sure that it's all working. So let's make even a main here. I just realized we don't handle arrays in functions like this, do we? Okay. We might not. Well, no, actually, I think we do. I can even test that out. So, yeah, that's what we would expect then. Turns an int and that. Yeah, so let's return 0 like that, and we'll just do, let's say with x1. Try that. And then we'll call this with x. Let's actually make it x3. Like that. So we'll call that, and that should exit with 2. And I'll change this to make sure it's 0. Okay, yeah. So I just want to try that. Make sure it works. Does still exit with 2. Okay, so I guess we can do that. I completely forgot that I actually made it general enough. That's pretty cool. So if I change this to x0, it should be exit with 1, right? And there we go. Okay, that's very cool if that actually works. Yeah. I don't think we support this. So I'm kind of getting off the topic of arrays, but I would like this to work, like no arguments. So then we could call this, and we could set y main, and then exit with y, and it should exit with whatever we put here. So I'll just put 5, so that it's not, whoops, it's not something that I accidentally do. And if I run it, yeah, it does not work. Okay, so I would like to get that working out. So this is sort of off topic, but still, it makes that. That's going to be entirely in the front end, specifically the parsing, right? So we encounter an identifier, and it's just in the node where it is a open parenthesis. Yeah, so we do this. Close paren. Okay, yes, that means we don't have a close paren. So then token. If it is colon, then it's function declaration, right? So that is that is still right, I think. Okay, so like we still should be able to get to this point, and then we do this, and but we consume a token. What is the token that we're consuming? Because in this case, we'd be consuming the identifier, right? Because we set that here. Yeah, so that's the identifier that we consume. Then we do this. Well, it's greater than 0, and it is not a closed brand. Then we do all this. And then we consume this is the closed parenthesis. Yeah, so why doesn't it work? I might have to set through it in GDB to test why it does not work. And where would that error come from? Let me make that specifically. So expected type colon, but found type n. So we're probably calling a token expect. Let me just print out and see if we get here. See if we get to that point, because we should be in here. Maybe even higher. Make sure we get in here, that it recognizes it as a function declaration, right? It's gonna do that, and then run. Okay, so we are in there, so that's good. And I'm assuming we don't get to the end, because otherwise it's a problem outside of this. Run. Okay, yeah. So that's good. So it's somewhere in here. So token consume. Oh shoot, I think I know what it is. So, no, because that consumes the open parenthesis. Wait, so why do we have to do this other consume? Oh shoot, because that's for the colon. I see. So this should be the colon. So if I print that here. Okay, so now we should be on. Actually, I'm not sure what we'll be on. Items. tokens dot data 0 dot type, like that. And I did this wrong. Okay, there we go. Like that. All right, let's see how that looks. There we go. Okay, so we didn't print anything here. Expected type colon. Where do we expect? Token expect, you know, in here? I don't see any. Actually, do we call any? Oh, shoot, we call parse variable declaration. That's what it is. Shoot. Okay, I see what's happening. Yeah. I understand. So basically, we call this, and we're on the open parenthesis. So we try to do this one time. Yeah, so that's where it's failing. It's failing in there. So I think what we have to do is peek ahead by 1. And then, yeah, let's try that. So, and, token peek. Tokens, and then, not I, but 1. So peek 1 ahead. And then, well, it is not that. And then we can just, I think we're gonna have to add a token consume in here. Right, because we're peeking ahead. So we're on the, well, no, because that is handled in the variable declaration, if I'm not mistaken. So we should have to do that. Is just do 2 token consumes in here. Right. Let's see. That should be about right. I run this. Assertion failed. Okay. Yeah. So let me print what the token is here. Tokens dot data 0 dot type, and this is actually I want to print token types, and it's just a way to stringify the type essentially. Let's see what it is. It's a colon. Okay, so we're on a colon in this one, so we have to do another consume. Consume tokens. And I need to test as well to make sure it works properly. Expected integer, but found that. Okay. So that's another issue. Oh shoot, because that's in here. So that is that. So that's gonna actually fail as well if I do that. But that is outside of that. So I need to work on that after. I want to make sure this works though. So I need to modify this and make sure I can still put something in here, you know. So let's see that's in. And then we'll, you know, do all that. Expected type colon, but found type ident. Okay. So I think we have to do another token consume here. Colon found type. So now we consume 2 many items. No, because this is the identifier that we're consuming. So right on the top is going to be the identifier. So if we consume that, then we have the open parenthesis, and then we have the rest of the stuff. So that is actually fine. I want to make it general instead of which program I use. Something else I could do though. I guess we count. Well, no. Let's see. Build, run. Type colon. Yeah. Let's print what that type is here. Types. Tokens. I really should make a function for this where I can just pass in like print type or something like that. If you know what I'm saying. Let's see what both of those are. Okay, open. Yeah, so we need to consume another one before we get here. And that. Okay. Yeah, because before we were consuming in here, right up here, and that was consuming that one. But we can't just only consume here. That does not work. Why did it expect that? Right, let's do 3G and then 15L. So is that with this? Is that thing after? Let's see. No, we don't get out of this point. So we're on. Yeah, so we consume 10 times when we do that. So it's hard to tell. So this first one works. And then on the second iteration, we have consumed, well, no, there shouldn't be a second iteration. Oh, shoot, that could be where the issue is. So, okay, let's try to modify this, perhaps. We're putting at the top, so at the top of the stack. No, that's not even, let's change it back to the token consume. And I'll have to try something like that, right? Consume, like that. Tokens. And then, we don't need this. And it's gonna break some other stuff, but let's try that out. And it did actually compile, I think. Okay, yeah, it didn't work because we have all these extra consumes here, so I think we needed just one of those. And 130. But it's kind of weird that this did not fail. I don't remember how many there were before, though. I'm trying to get it back to how it was before. Yeah, so that is not right. So let's see what we're looking at here. We have token consume. Well, it's not that. Okay. Alright, so we have that fully compiles, but okay, it did actually work, so I must have typed another correct. Okay, so this is how it was working, how it was before when it was working. So this works, but now with an empty one, it will not work because it calls this. So, yeah, I think what we have to do is go back here, right? So we go through this. We have an I in there. So, how can we do this? So if I equals 2, printf I, see what it is each time. So go back. So I is 5. Okay, yeah, that actually, so that, well, it's token, so, yeah, if we get rid of that, what is it going to be? Then it's 2. Okay, that is what I thought. So if it's 2, then we know that there is no arguments, right? So I think we can use that, right? We can use that to our advantage. So if, I is not equal to, and that, then we'll skip over this if it is 2. Even be greater than 2. If it's any less, though, there's probably some error, but we'll worry about that later. So then we skip over it, right? Maybe we want to token consume first, though. So we can do that, and do and is greater than 2. So then it will execute it in that order. And then, if I do this, yeah, so it still fails, as expected. So now I need to modify it to properly work. So what is the token that we're on here? Is a colon, and we want to be on the type at this point. So, actually, let's see, if I do this, then is it the same? Then we're on the close parenthesis. So we need, like, yeah, okay, so that was actually better. Let's get rid of this. Okay, and so what we're going to do is if I equals 2, then we want the token consume again. Because that means that we're at that point. So I'm not sure if this is great, but it should work. Yeah, and then args. Oh yeah, because we call it like this. So we need to handle this now, which actually could be easy as well. But now this seems to work. So, yeah, and it should work for both of them. So if I actually modify it to take an argument, I just want to make sure it works here. Pass in 15, right? Should exit with 15. And exit with 0. What? That's not right. Fire, 10. 0. Why is it 0? Shoot. That could be bigger problem. Yeah, okay, so that's a problem then with that. So I need to, it's probably from the stuff we were doing with the args earlier. So I will figure that out. First, I want to get this working. So when parsing a function call, yeah, we sort of have the same problem here. So I think we can do pretty much the same thing. And I do. Then we have no args. We have to fix that. So let's see. So let's change this. So that should fail. Integer would found that. Okay, so that might not actually work. Okay, because now we have to modify it in the actual generation because it's trying to to parse something that does not exist. So if it's 0, we need to consider that. So let's do let's go to gen programming and let's look at the function call. Okay, and well, just less than that. So what is this? No, actually, that's a different issue. Oh, shoot, because we're trying to parse expression. So it's still in the front end. But it's where we're calling parse expression. So where do we do that? Actually, hang on. Okay. What do we get? We call on that. No, we don't. Oh, I don't want to print I anymore when I'm doing that up here. Yes, we're not calling that. So what is the deal with this? Where are we calling parse expression? That needs to fail. Integer, but found close. Shoot, do we need to do any other token? Let's see. Yeah, okay, that actually makes sense. Token. If I equals 2, then do that. No, hang on. What? Let me just, let me check this, right? That. Did we get 2 of those? No, we didn't get any of them. Wait, what? What the heck? So we don't get to this point. We get here. We should get here. Okay, we get to the end of that. Maybe I should step through in GDB and see where we actually fail at. So let's do GDB. Shoot, I forgot to break. Well, that's fine. We don't need to break actually. So, expect to ensure we found that. Why did it not jump to that point? I wanted to see where it happened. Alright, let's just let's break on parse. Whoops, hang on. Break on parse. And then we'll run. Okay, let's step through. Let's see when it actually breaks. So I'll just get through here quickly. Yeah, so this is the function, so we go through all that, and then we go here. Else. And then, okay, now we're here, in the return. Now we're here. Why are we in it? Oh, shoot, now we're in it. Wait, hang on. Alright, let's just see. I think it got a little messed up because we printed stuff out, so it's, like, not correct. It's gotta be in here, right? Alright, let me get rid of that print statement, because that kind of threw everything off. I guess I could get rid of that. Pretty good. Let's quit that out. Let's try that again. That's fine. GDB, that's happening. Break on parts. And run. No, run and run. Wait, okay. Okay, step through this. So, should be in the correct place. So let's go until the next identifier. Oh shoot, I know what it is. It's in the parse expression. Yeah. In parse expression. The function of it. Let's see. Is that already in the parse expression? No. What does it return? Oh yeah, it returns an expression. Okay, I don't know. Parts expression, yes, we have this. And here is the parts part. Yeah, that's actually what we're looking for, parts part. So we want to look at, and that is there. Okay, so, what is this? So this is a fun call, and we consume all of that, and we set the arc. So let's do, shoot. We're creating an expert fun call, and then what do we have to, we need to basically check if, right. So token P0, that means the top. So if, let's see, what we can do actually is, can we just, yeah, we can just return the expression. So let's, if, well, token consume. Actually, here, we have to do this. So we consume it, and that's the open parenthesis. So we want to do that, and then we want to do and. Okay, shoot. Yes, what we have to do is this. So let's do if, token P, token 1. We don't have to do that. Token 1 dot type equals the close bracket. Then we need to, double token consume. Right. And then we need to, return because there is no arc. So we need to actually set, no, it'll just be 0. So then we should be good to do that. And yeah, so I don't do that. Okay, let's try that out now. And it did compile, and it looks like it would. Okay, so now now I need to, well, I'll alternate this. Yeah. Let's see, change. Yeah, so pushes capacity. Really? Okay. There was not much that changed. Alright. Okay. Yeah, so now you make it so, the arts work, because those actually broke. Let's see, so, X, and we get past it here, and if we return it, it is not returning properly. Yeah, okay, so is it because of the name? If that's the case, that is not. It is because of the name. Okay, so it's trying to grab the array. That's what it is. Let's look at that. Let's look at the code. So it's trying to print out the array, I suppose. Can we not has them? So when we yeah, this is writing to the array. Variable. Push 5. Call main. And main is where? Main is right here. Indupe 1, so 0, 1. So I'm gonna have to step through it. But it's trying to grab the array. That's not what it means. If I get rid of the array, then it works fine, right? Yeah. Okay. I obviously want to be able to have that not do that. So let's see. Yeah. So this all seems to be working now. So that's cool. That is cool. So let's go to the back end, and it's gonna be in here. When we're grabbing it, oh shoot, actually, I need to think. So where's it gonna be? It's gonna be in gen expression, right? Gen expression, right here. So in this case, we're grabbing a variable, get variable location. So this is where it's failing. Well, it's not necessarily failing, but it's grabbing the wrong one. Let me actually let me make it a simple example so it's easier to work through, right? So let's make it a single element. Let's do that, and let's see. So then it is still not working. We have this. So this is the function declaration. So yeah, we go through all this and we allocate the array. So let's see what's gonna be on this app. We push 8, 1, multiply them together, so it's still 8. Yes, that's the size, and we allocate that. So that pushes 2 things on the row, pushes on the array, pushes 8, and then the pointer, right? And then we duplicate the pointer, and we push 0 and add to the pointer. Yeah. So we're good with that. Pass it back to a pointer, all that stuff. Push 1, push 8, and we write to it. So that writes 1 to it. So that consumes both of those and the pointer, that extra pointer. So we're good with that. Then we jump to label 0, so that skips over that. And we push 5, so then we have, whoops, we have 5 on the stack. And in here, yeah, it's in dupe 1, so it's grabbing the wrong thing. So when we call a function, call function equals get func, so that's all fine. Then we do this. Ten expert. Alright, so that must be wrong. That's what. Oh no, that's actually right, because that's the function call. But then in the function declaration, we're missing something here. Plus stack size. Alright, let's see. So when we get to that point, the stack size would have been 2. So we'd have 2 elements on the stack. So why is it trying to do 1? What is it? Why does it think that's the stack? Let's print the stack size in here, right? When we if size is that, and we can get a good idea of what it is at. State stack size. It's probably run through in GDB as well. I might just do that. Not print anything. What the heck? Did not rebuild. Oops. Why did it not? We have a function call. Oh shoot, but it's not a function call, you know? It's in the, yeah, it's in the expression. Yeah, that's right. Yeah. I just made a little stupido. Let's see. Gen expert. Okay, right here. Fun call, so it's this. This one is not working. Yeah, so let's add a print statement here and see what it is. Okay. That size is. What is it? Well, actually, it's not even. So that is the thing. Got the zoo. Okay, let's try that again. Stack size is 3. Okay, that's actually correct. After pushing that, so it's fine in there. So it's probably gonna be in here. What does it think the stack size is on the function declaration? Func deck. Right here, what does it think the stack size is at this point? At stack size is state stack size, because then it's gonna be 1 greater than that it pushes. 2. Okay, so then 3. So push that at 3. So why does that happen? Because then it would just be 0. So I don't get why it would generate that. Why it makes this, 1 when it's trying to get it. Let's go to return then. Type return. What's the stack size? State stack size. That should be 4 actually at that point. 4, okay, and that's correct. Where do we and what's the value dot well, man, I can't really get that. Let's see. Alright, I might have to use GDB for this. To just step through it. Let's try that. Then we compile it. Let's change. Enable. Let's break on then program. And let's run thing. Alright, I might have to go, so I might work on this off camera. So let's step through it. So let's see. So we have the variable declaration, so that is all good. Alright. I'm gonna open a new tab here. Just I don't need to whatever. Fine. let's go in here and what? Oh, ls. There we go. Let's look at the Kano. So we have this first. Really, what I want to look at is what is grabbing here. That's the thing that I want to consider. What value is grabbing there? So that is going to be not here. This is fine. That's all totally fine. It's going to be on the next one. So function declaration. Okay. Right, so print state stat size is 2. It becomes 3, so that's all fine. But it's actually when we get the variable name. So let's see. When we so we get var. So this index that it's getting is wrong. Yeah, I should print this out. Let's see what that is. So I'm going to quit out of this GP because actually I'm not sure that's going to be very helpful. And that's okay. So it prints out. Where's the other thing that it's printing? And where is that? Or does it print out twice? That actually makes sense. Yeah, okay. So what I want to do is print out the variable name when I do this as well. And actually that makes a lot of sense. That is getting that variable. Hang on, so how do I handle that? This is when we return though. No, this is view plus that. View r, whoops. View r expert value dot variable. Format string is fine here. Variable dot name. That works. No. So that is right. What's the issue? Hang on. Specs a 19 size type argument. Oh, because I forgot the comma. Okay. And yeah, this is actually, it's not even that, so I changed it so I don't get warning. And there, okay, so that works. And let's run this. X is 2. Okay, so that's where the issue is, because it places at 2. But that would be right anyway. And then why is that? And if I change this to be like L, then X is at 3. Okay, so that's what it is. It's definitely grabbing that. So what I need to do is, yeah, because we're just iterating over it. So actually, I don't know how I was handling this before, because I had this working, did I not? Right, so if I get rid of that, let's make X equals 15. Does it grab that? Huh. Oh yeah, X can't. Anyway, program my own language, okay. And X is with 15. So yeah, that is the same problem. So, huh. I thought I had fixed this problem, but apparently not. So, basically, we need to consider the scope here. So it only should grab one that's within the scope, you know? Yeah, so that's sort of like the whole problem here. Basically what we have to do is we could pass the scope there, or we could, what do I really want to do for this? Because actually, is that even actually, if you're referencing that, how does that work? So like, let me make a Python, right? And let's do x equals 12. And then x, right? Equal x. That's not how you Python. Think x. So I do that, and then do that. X is parameter and global. Okay. So yeah, that is the issue. Does that? Yes, that works. That just takes that one. Okay, so maybe this is an error that we should throw if it's a global variable. Okay, yeah, so this is sort of something I had to think about more. It's not a big deal though. So just naming variables better. Yeah, okay, because it works like this. So I'm gonna probably look into it off camera, and I'll probably just throw a warning if you put the same, put the use that as a parameter or something like that. I'm gonna have to think about it. But yeah, so this will work. Okay. Yeah. So I will think about that. Okay. So I guess that is gonna be the end of the video. So thank you for watching, and I'll see you next time.